Hello, Math 141. We want to solve some inequalities and use interval notations for our answers. So first, let's start with something really simple. Something like x plus 4 times x plus 2 times x minus 3 smaller than 0. So I know in your textbook it shows for us to make tables of values and on, but I really don't have that much room in my iPad. So I'm going to show you a very old-fashioned way of doing this uh, to do the same process and hope you like it. I think you're going to like it. So first thing I'm going to do, I'm going to just put a number line in here. You can think of this also as the x-axis, which is the same thing as number line. And I'm going to find the critical points that I need. So you can say that this is x-axis or number line once again. Looking at this, I know that at x equals -4, I have uh, an x-intercept. So let's say that -4 is somewhere in here. And let's say I get something -2 in here. And let's say +3 somewhere in here. And now I'm going to test numbers to the left of -4, a number between -4 and -2, and a number between -2 and 3. So first I'm going to start with a number to the left of -4, say -5. If I plug in -5 in the first parenthesis, I get a negative, then I get another negative, and then I get another negative. And negative times negative times negative is negative, and is a negative. So this equals to negative, and a negative is smaller than 0. So I do have a true. All these values in here to the left of -4 give me true statement. You can plug in any number in there. Say, just you don't have to, but for the sake of discussion, let's say -10. Well, -10 in here gives me uh, a negative value, and then a negative value in here, and negative value in here. And negative times negative times negative is negative. So every value to the left of -4 gives me a true value. How about -4 itself? Notice that if I plug in -4 in here, I get a 0, and 0 times anything is 0, and 0 cannot be smaller than 0. So I'm going to put little f for -4 for false, or false. For -4, I'm going to put false. How about a number between -4 and -2? Let's say -3. If I plug in -3, I get a positive value in here, I get a negative value in here, and I get another negative value in here. And positive times negative is positive. And positive value cannot be smaller than 0. So I'm going to put also false in here. False, all the values between -4 and -2. How about -2 itself? If I plug in -2 in my original inequality, notice that I get a 0 in here. And 0 times anything is 0, and 0 cannot be smaller than 0. So I'm going to put false for -2, false for -2. How about a number between -2 and 3? Say 0. If I plug in 0, this gives me a positive, this gives me a positive, this gives me a negative. Positive times negative is negative, and a negative value is smaller than 0, so true. for these values. And how about positive 3 itself? Okay, 3 minus 3 in here will give me a 0. 0 times anything is 0, so that gives me a false statement. And how about to the right of 3? Say 4. If I plug in a 4, in first parenthesis, I get positive. Here I get positive, and here I get positive. And positive times positive times positive is positive. And a positive value cannot be smaller than 0. So false again. So now, using interval notation for the answers, I can say that from negative infinity all the way to negative 4, I have the values that would make this inequality true, together with or union from negative 2 to 3, and negative 2 and 3 are not included. So at this point, some of you ask that, did I really have to test this critical point in here, and in here? I know I don't have an equal sign in here, so I knew those values are going to give me a false statement. And the answer is, so long as you have a polynomial, that's true. You can use that logic. And in this case, you do have a polynomial. But if you have a rational function, a function over a function, sometimes these critical points can make the rational functions undefined, so they have to be excluded. Let's do a more interesting example. Suppose I have 2x cubed minus 18x smaller than x to the second minus 9. Bringing everything to the left-hand side, I would have now I have 4 terms. I'm going to use factor by grouping. Here's one group, here's the other group. And I'm going to factor out from left group x squared. So I have 2x minus 1. On this second group, if I pull a negative 1, then I get 2x. Ooh, look at this. This, taking it to the left-hand side, is positive. I have to be careful with that. Adding 9 to both sides gave me positive 9. So I have 2x minus 1 in here, smaller than 0. So these two are identical. Factoring it out, I get 2x minus 1, and then x squared minus 9, smaller than 0. I have difference of 2 squared in here. So I have 2x minus 1, x plus 3, x minus 3, smaller than 0. Let me put the x-axis or number line, whichever you prefer. Okay, so testing or setting my factors equal to 0, this gives me positive 1/2, somewhere in here. This gives me negative 3, say somewhere in here. And this one gives me positive 3, somewhere in here, positive 3. Now, if it tests a number to the left of negative 3, let me say negative 4. If I plug in negative 4 in here in the first parenthesis, that gives me a negative number. The second parenthesis gives me a negative number. Third parenthesis gives me a negative number. And negative times negative times negative is negative, and negative value is smaller than 0. So I'm going to put here T for true. I know negative 3 right here is false. because this is a polynomial and I don't have equal sign. You could also reason that when you put -3 in here, that gives you a 0. 0 times anything is 0, and 0 cannot be smaller than 0. Okay, so how about a number between -3 and 1/2? Let's say 0 is a natural choice. If I plug in 0 in here, this is going to give me a negative number, this is going to give me a positive number, and this is going to give me a negative number. And a negative times negative is positive, and a positive number cannot be smaller than 0, so false. So I don't have any solution between -3 and 1/2. I know 1/2 itself is going to give me false. Once again, if you plug in 1/2 in here, that gives you a 0, and 0 times anything is 0. 0 cannot be smaller than 0. Between 1/2 and 3, let's say 1. If I plug in a 1 in here, I'll get a positive, and a negative. The end result is negative. A negative is smaller than 0, so I'm going to put T for here for true. I know 3 itself is not included. Once again, you can reason that if you plug in 3 in here, 3 minus 3 is 0. 0 times anything is 0, and 0 cannot be smaller than 0. And how about to the left of, how about to the right of 3? Sorry about that. How about to the right of 3? Say 4. If I plug in 4, I get a positive in here. I get a positive in here. I get a positive in here and a positive in here. Positive times positive times positive is positive. So, and a positive value cannot be smaller than 0, so false. So what is my, what are the intervals that give me true statements? Or the my solutions are going to be from -infinity all the way to -3. -3 is not included, together with from 1/2 to 3, and 1/2 and 3 are not. 1/2 and 3 are not included. So I think we have time for one more. Suppose I have, let's do something a little bit harder. How about this? How about 4x to the 4th minus 25, x to the 2nd plus 36, smaller than or equal to 0. Okay, so let's see, I'm going to just use u substitution. You don't have to. You can right away say that, this is going to factor to 4x squared minus 9 and x minus 4. Okay, smaller than or equal 0. Okay, but let's say that if you just didn't know, if you couldn't see that, what could you say? You could say that let me open. You could say let u equals x to the 2nd, therefore u squared equals x to the power of 4. So now you could rewrite this inequality as 4u squared minus 25u plus 36 smaller than or equal to 0. And now you could factor that to 4u minus 9 and u minus 4. And remembering that u, in fact, is x to the 2nd, you could say that this is the same as 4x to the 2nd minus 9, and then x to the 2nd minus 4, smaller than or equal 0. And gosh, look at this. I forgot, I totally forgot to put my X coord in here. I apologize for that. Okay. Now I have difference of two scores in here, and I have difference of two scores in here. So I'm going to break that down to 2x plus 3, 2x minus 3, x plus 2, x minus 2, smaller than or equal to 0. And so let me just get rid of all this, give myself a little bit of room. And now I'm going to go ahead and put my number line using the critical points. And I think I'm running out of time. So the critical points are, this one gives me x equals -3/2. So somewhere in here, -3/2. This one gives me x equals +3/2. So let's say in here. This one gives me x equals -2. So say here. And this one gives me +2, say here. Okay. And testing numbers in between. If I plug in number to the left of -2, let's say -3. If I plug in -3, then this is going to give me a negative. This is going to give me a negative. This is going to give me a negative, and this is going to give me a negative. Okay, and so the end result is positive. A positive number cannot be smaller than or equal to 0. So I don't have any solutions to the left of -2. 2 itself is 2, -2 itself is true, because when you plug in -2 in here, that's 0. 0 times anything is 0, and 0 is smaller than or equal to 0. Between -2 and -3/2, if I plug in a number, let's say -1.9, plug in -1.9, it gives me, so let's see, 2 times, yes, it gives me a true, and you can use your calculator. I'm running out of time. So this gives me a true statement. -3/2 itself is giving me a true statement. Between -3/2 and +3/2, let's say 0, that gives me positive, positive, negative, positive, and negative. So the end result is going to be positive, so false. I don't have false. And let me put this true in here, put it in red to be consistent. Between 3/2 and 2, let's say 1.9, okay, that gives me, yep, true. And after 2, let's say 3, plug in 3. This is going to be positive, positive. Well, everything is going to be positive, so false, no solution. And 2 itself gives me true. Why is that? Because, if you plug in, when you plug in 2 in here, you get a 0, and 0 times anything is 0. So the interval notation, using interval notation, I know my answers are, and from here, between -2 and -3/2. So -2 is included, -3/2 is included, together with from +3/2 to +2. Okay, and remember that how did I know that this 3/2 is included? If I plug in 3/2 in here, I get a 0. 0 times anything is 0. I also didn't need to actually do any work for that because this is a polynomial. This is not a rational function. So I do have an equal sign here is smaller than or equal to 0. So therefore, all my critical points are included. Well, I hope you like this method that I showed you. And I really don't know who to give credit to this method. I learned it in high school years and years and years ago. And so credit goes to somebody, anybody, but not me. I hope you enjoyed this video and thank you.